More images from the James Webb Space Telescope are surfacing, and this time it features an almost perfect Einstein ring. The stunning halo is the result of light from a distant galaxy passing through warped space-time surrounding another galaxy aligned between the distant light source and Earth. The new image, which was created by a Reddit-based astronomy enthusiast, is one of the best examples of the trippy astronomical phenomenon ever captured. To know more interesting news about the stunningly captured Einstein ring, stick with us right till the end. The ring of light in the new image comes from the distant galaxy SPTS J0418394751.8, or J0418 for short, which is around 12 billion light-years from Earth, making it one of the oldest galaxies in the universe. J0418 is oriented directly behind another galaxy, the bright blue light at the center of the ring, which is so massive that the gravitational pull warps the space-time around it. As light from J0418 reaches the foreground galaxy, it travels through this warped space-time. From Earth, it looks as though the light has curved around the galaxy, but the electromagnetic waves we see have actually been traveling in a straight line the entire time. This weird effect is similar to how glass lenses direct light. Like magnifying glasses, this phenomenon also makes the light from the distant galaxies appear much closer than they actually are. The only difference is that the lens is made from gravity-mangled space-time instead of glass. As a result, researchers have dubbed this trippy effect gravitational lensing. Albert Einstein first predicted gravitational lensing in 1912 when he devised his theory of relativity. NASA's Hubble Space Telescope has also captured images of several other Einstein rings, including one formed from warped quasar light. However, none of these Einstein rings was as complete or clearly visible as the one in the new image. We'll talk about this later in the video, so make sure you stay with us right till the end. Reddit user and astronomy grad student SpaceGuy44 posted the image of JOS-18 Einstein ring August 23rd in the subreddit r/astronomy. The anonymous astronomer created the shot using publicly available data collected by the Mid-Infrared Instrument, MIRI, on the James Webb Space Telescope. We wouldn't be able to see J0418 if it weren't for the light-bending properties of gravity, SpaceGuy44 wrote on Reddit. Without the lensing effect, the galaxy would probably look like most distant galaxies, a small blob of light. The new image is not the first glimpse of J0418, but it is by far the most detailed yet. In 2020, researchers discovered the distant galaxies after spotting partial gravitational lensing with the Atacama Large Millimeter/Submillimeter Array, ALMA, in Chile. They reported the findings in a paper published that year in the journal Nature. On August 13, SpaceGuy44 released an image of J0418 using data collected from Webb's NIRCam instrument, but the initial shot had much lower resolution and the ring of light was less visible, according to Science Alert. Perfectly circular Einstein rings are extremely rare because they require both the distance and foreground galaxies to be perfectly aligned with the observer. However, the more advanced sensors on James Webb should make it easier to spot them in the future. The recently released photo is just the latest example of the high-definition view of the cosmos that Webb will provide to both researchers and the general public. The Space Telescope, which released its first pictures in July, has already snapped a stunning infrared image of Jupiter, a mesmerizing view of the Cartwheel Galaxy, the deepest image of the universe ever taken, and other jaw-dropping photos. Hubble captures an Einstein ring. A new photograph from the Hubble Space Telescope shows a stunning Einstein ring billions of light-years from Earth. The round object at the center of the photograph, released by the European Space Agency, is actually 3 galaxies that appear as 7, with 4 separate images of the most distant galaxies forming a visible ring around the others. The farthest galaxy, a special type of very bright galaxies with a gigantic black hole at its center, known as quasar, is about 15 billion light-years from Earth. At such a great distance, it should be invisible to even the best telescopes, but its light is curved by the 2 galaxies in front, about 3 billion light-years away, so its image appears to us in 5 separate places, 4 times in the ring and once at the center of the ring, although that can be detected only in the telescope's numerical data. Telescopes in Einstein's time weren't able to detect any other signs of the phenomenon. It was seen first by astronomers at the Kitt Peak Observatory in Arizona in 1979 as twin quasar QSO 0957+561, a single quasar that looks like 2 here on Earth because its image is gravitationally lensed by a closer but unseen galaxy. Since then, astronomers have discovered hundreds of Einstein rings. The alignment of the distant galaxies needs to be perfect, and none can be seen without a large telescope. A common formation is the Einstein cross, in which a distant galaxy appears as 4 separate images around a galaxy closer to Earth, but the closer galaxy is too dim to be seen. Einstein rings and Einstein crosses are more than just pretty phenomenon. Gravitational lensing allows astronomers to look much farther into the depths of the universe, and it reveals otherwise hidden details of the galaxies that cause the lensing. The Einstein ring and Einstein crosses are presumably evidence of more material in the closer galaxies than meets the eye, and that most likely means dark matter, said the astronomer Ed Krupp, the director of the Griffith Observatory in Los Angeles. Their distribution can help illuminate the identity and distribution of dark matter and the relativistic geometry of the whole universe. Such gravitational lenses have also spotted some of the most distant dwarf galaxies in the universe, which, being among the oldest, can tell astronomers more about galaxy formations, while gravitational microlensing, variations in the light from individual stars, has revealed the unseen presence of distant exoplanets, Krupp said in an email. And with that, we've reached the end of the video. To watch more fascinating videos, make sure to subscribe to our channel and also press the notifications bell. See you at the next one.